Good everyone, my name is Graphics. Today we want to simplify this example in indices. Now this is how we are going to start. We are given x equals to this, right? And we know very well that whenever our x or a variable with the power is coming up, it will have a negative sign attached to it, right? So I'll now write this to be x is equals to, I'm having my x to the power of what? A. Now when this x is coming up, we multiply by what? X to the power of what? Minus what? Minus b, to show that what? It has come up. So I'll put it into the brackets and I'll put my 1 all over what? AB. Multiply by, the same thing happens here too. I have my x to what? To b. And if the other x denominator that is s to the power of 6 coming up, I'll be having my x to the power of what? Minus c, to show that it has come up. I close it up. The next one is I'm having x to the power of c multiplied by x to the power of what? Minus a. Everything is to the power what? 1 all over ac. This is 1 all over bc. Right? That is the first stage. So this happens when you say recall, where you have a to the power of m all over a to the power of n. It will give us what? am multiplied by a minus n. Right? So that's what we're having. So now move forward. Now from here now, we have x equals to, this will give me s. When you have two variables that have the same base multiplying each other, you're going to add the power. So this will give me a plus bracket minus b, right? I'll close it up. I'll be having 1 all over ab multiplied by x. We have b plus bracket minus c. I'll close it up and I'll be having 1 over bc multiplied by, I have this also, x to the power of c plus minus a, and this will give me, we have 1 all over what? ac. So this means recall when you have am times, when you have am times an, it's going to give you am plus n. So this is another law again that governs it. So we move forward. From here, I have x, a plus, this is plus times minus is minus, so I'll be left with what? A minus b. So I have 1 over what? ab. I open the bracket again, the other one, I have x. Now if I add these two, plus times minus will give you minus, I'll be having b minus c. Close it up. Close to it, I have 1 over what? bc multiplied by the next one, I have x. We have c minus a. Close it up. We have 1 over ac, because plus times minus is minus. That's what I'm having. Now what do you notice? I have the same base multiplying each other. It means before that I need to multiply this. How will I do that? Recall, if I have am multiplied by what? N to the 2 powers like this, I'll be having amn. That's another law. Now we'll move forward. This will not give me from here. This will give me x to the power of what? We have a minus b times 1 will give you a minus b over what? ab multiplied by another x. We have b minus c over what? bc. This is like saying over 1. This is like saying over 1. So the numerator times numerator, a minus b times 1 will give you a minus b, 1 times ab will give you ab, b minus b times 1 will give you b minus b, 1 times bc will give you bc. So multiply by x to the power of c minus a is like saying c minus a over 1. So c minus a times 1, c minus a, 1 times ac will give you what? ac. Right? Now, we apply the law. This same law that we have here. Let me just write it out. Recall am, or let me say ax times ay times az. It will give me ax plus y plus z. You're going to add all the power, even though there are more than one. You take one of it and add all the power, and this will not give me from here. I have my x. I'll be having a minus b over ab again plus b minus c over what? bc plus c minus a over ac. So that is what we're having. I've added the power. Now the next thing we're going to solve this variable in fraction, and I'll be having this will now give me x. The LCM here, I have, what are the total variable I have is 3, which is what? ABC. So ABC is the LCM. So A, B, C. You're not allowed to repeat 2 values in the LCM. Now this is AB. AB in AB is remaining C. C times A minus B will give you C into bracket what? A minus B. Right? Plus BC in BC cancel, we have A. We're having A into bracket what? B minus C. Right? So from here we have this. So move forward. AC in AC, this AC is remaining just B. So B times this will give you plus what? B bracket what? C minus A. So this is what we're having here. Now we're moving forward. This will now give me, I have my x. C times A will give you, we open a bracket, AC minus C times will give you BC plus A times will give you AB minus what? AC plus B times C will give you what? BC minus what? AB. B times A is like saying AB or BA. Now everything all over what? Everything all over ABC. Now if you look at it, I have a positive AC here and a negative AC will equate. I have a negative BC here and a positive BC will equate. And I'm having AB here and I'm having minus AB here. So in the long run, I am going to be having x to the power of what? Everything here is giving me 0. So I'll be having 0 all over what? ABC. Now recall 0 all over any finite number. 0 all over any finite number, like 0 over 1, 0 over 2, 0 over 3, 0 over 4, 0 over 1 million, will always give you what? 0. Are we good? Now that will mean that my x raised to the power of what? 0 will be equals to what? Will be equals to 1. So my answer here is 1. So meaning that what? X is equals to what? 1. If you know you've benefited from this video, just click on the subscribe button and like. Now our next exercise here will be, the next question says, if 1 minus x8 is equal to 65 and 1 minus x to the power of 4 is equal to 64, find x. Now we know very well that we have two different equations here. We have, let me call 1 minus x8 equals to what? 65. I can call that to be my equation 1. And also 1 minus what? x4 be equals to what? 64. I'm going to call it what? Equation what? Equation 2. Now in this equation 2 here, I can find it in equation 1. So what I'm going to do here is this. Now I'm going to break this equation 1. How will I do that? I will do that in this manner, right? And it will become like this. From equation 1, right? From equation 1, I have 1 minus what? x8, right? Equals to what? 65. Now I can break it down. This my 1 here can also be, I want to take it in the form of this equation 2. So I can put it this way and say that my 1 minus x to the power of what? Power of 4, right? Now I'm having this 4. What will I multiply with this 4? That will give me 8. And that is what? That is 2. Right? So equals to what? 65. Similarly, my 1 can also be written as what? 1 square. My 1 can be written as what? 1 square. Now I'm having difference of what? 2 square. Is that taken? So how will I do that? Difference of 2 square means that recall, when I have a square minus b square, it's going to give me a minus b into bracket what? A plus b. So what I will do here is, this is 1 square, so I'll have 1 minus x4 into bracket what? 1 plus x4. So that is the difference here, equals to what? 65. Now if you look at now, but 1 minus x to the power of 4 is equals to what? 64 in equation what? Equation 2. Right? So anyway, I see 1 minus x4 here. Let me call this to be my equation 3 here. So put in equation 3. Now in equation 2, right? So substituting in equation 3, substituting in equation 3, Roman figure 3, this will now give me, so I'm writing 1 minus s4, I'm going to write what? 64. So I'll be having 64 into bracket 1 plus x4. That is what I'm doing. So equals to what? 65. So I'm putting 64 in this. So I'll now write it out. Now from here, what will I do? I am going to divide both sides by what? 64. So dividing both sides by 64, I'm going to be having 1 plus x to the power of 4 is equals to what? 65 over what? 64. I divided both sides by that. So from here, I'll take my 1 to this side here. So my x to the power of 4 will now give me 65 all over 64 minus 1. So you solve this. This will now give me x4 will now give me the LCM here is what? 64. 64 and 64 is 1. 1 times 65 is 65. Minus, I have a silent 1 here. 1 in 64 is what? 64. 64 times 1 is what? 64. So from here, the x4 will now be giving us 65 minus 64 is what? 1 all over what? 64. Now the key word here is when this guy is coming here, I'll be having my x4. When it's coming here, it will become 1 over 64. It will turn to a root sign. And that will be what? Put the 4 here. That's when it's traveling to the other side. It becomes that when you have square, come to the other side, it becomes square root. So when you have 4, come to the other side, become the fourth root of this. Right? Now, from here, my x here now will now be giving us the roots, whatever root of 1 will always give you 1, all over. For 64, we'll be having, so it will be the root of 64, and I'll put my 4 in here. And this can be written as this. I can write this as this, saying that my x will now give me 1 all over 64 into bracket 1 over 4. If you watch my previous video, I explained this, right? And I can take 64 to a number in base 2 to give me 1 all over 2 to the power of what? 6 into the bracket of what? 1 over 4, right? And this will give me 1 all over 2 to the power of 6 all over 4. So 2 can go in 4, 2 can go in 6, 3. So my answer will now be 1 all over 2 to the power of what? 3 all over 2. Either you leave it this way or you say 2 to the power minus 3 over 2. So that will be my answer. So if this video was helpful, don't forget to click on the subscribe button. Thank you. For our next exercise, we are told in this next question that if x to the power of a is equals to what? Xy to the power of b equals to xy squared to the power of c, show that b is equals to 2ac all over a plus c. So what you have to do, first thing you do, you say let x to the power of a equals to what? Xy to the power of what? B equals to xy square all to the power of what? C, represented to be what? K. Right? So it simply means that my xa is equals to what? K. I'll call it equation 1. It means that my x y to the power of what? B is equals to K. It means that my x y square C, my sy square to the power of what? C is equals to what? K. That is what this means here. Now, let me call this equation 2 and call here what? Equation 3. So this can be given as, still my same equation 1, it can be given as x is equals to what? K. When this a is coming to this side, right, it will have 1 all over a, because the a here is over 1, so when it's switching sides, it will become 1 over a, right, which is something as saying square root of what? K. This is a here, but let's leave this, the a root of k, put it that way. Now we know our x is equals to k 1 over a now, so put x equals to what? K 1 over a in equation 2, right? Well, this equation 2 can also be written as what? My xy is equals to what? K 1 over b. When the b is coming here, become 1 over b, and also here will give me my xy square equals to what? K 1 over what? Over c. So I will be taking this in my equation 1, 2, and 3. So put x equals to k 1 over a in equation what? Equation 2. And that will give me x y equals to what? K 1 over b. So I'm using this. Now what is my x? My x is what? K 1 over a. So I'll put, anywhere I see x, I'm going to put k 1 over a. This will give me k 1 over a. Then put my y is equals to what? K 1 over b. Now if this is coming here, if I divide both sides by k 1 over a to make y stay alone, so my y will now be equals to what? K 1 over b all over what? K 1 over a, because I'm dividing both sides by what? K 1 over a. Now when this k 1 over a is coming up, it will become k 1 over b multiplied by k minus 1 over a. So when it's changing sides, this one will be minus to show that it's moving from down to up. Now from here, the law states that if you have two bases that are the same multiplying each other, you're going to add the power. So my y here will now give me k 1 over b, right, plus minus 1 over a, which seems as saying minus what? 1 all over a, because of this minus that is here. If there's no minus, I'll just put plus there. So this is what we're having, and my y will now give me, we have k, the LCM is what? AB, right? So we're having a minus b, because b in here will mean a times 1, or you just simply say a times 1 is a, b times 1 is what? B. So this is my y. Now we'll move forward. The next one, we are going to put x also in equation 3, just like you put in equation 2. So we have y now, which is equals to k to the power of x a minus b over what? AB. Now what are we going to do? We're going to put it in equation what? Equation 3, right? So what is our equation 3? Our equation 3 is telling us that xy square is equals to what? K raised to power 1 over c. So we're going to input that here. So we have x y square is equals to what? K 1 over c. What we have here. Now when you put your y, this y you put it here. Anywhere you see y, you put this guy here. So we'll now be having, substituting our y, substituting y equals to what? K a minus b over ab. So we're having x Our y here is what? K a minus b over what? ab, everything to the power of what? 2, because the y here has a square, equals to what? K 1 over c. Now we move forward. So from here, this you are going to expand that. There's a rule. Recall, if you have am to the power of what? N, to give you what? amn. So this will multiply this. So my x multiplied by to now be k standing alone. So the 2 will come to multiply a minus b, because it's the numerator, all over what? ab, equals to what? K 1 over c. Now if you divide both sides by k, this is the power of 2 into bracket a minus b, everything over ab, you'll be having this. My x is equals to k 1 over c divided by k 2 into bracket a minus b all over what? ab. You know we have. I divided both sides by this guy here. Now when this is going up, we'll be having this. This will now give me my x equals to k 1 over c multiplied by k minus what? 2 into bracket a minus b, everything over what? ab. Now because of I'm taking it up, it has a negative sign to it. Now recall, if I have am multiplied by an, it will give me what? am plus n, right? So this 2 here will give me x equals to, we have k 1 over c plus, but because there's a minus, it will be minus 2 bracket a minus b all over what? ab. Now this will now give me, we have k, let me make it bigger, right, equals to, the LCM here will be abc. That will be my LCM there, because I have ab here and I have c, right? So it will be abc. So from here, before you even do that, we know what x is from the beginning of our solving. Our x, if you check it, our x will give us k to the power of 1 over a. Let me show you. Our x will give us what? K to the power of what? 1 over a, right? So we'll take it up back. Now, so I'm writing x, I'll put k to the power of what? 1 over a. So we're still on track. Now, but x is equals to k to the power of what? 1 over a. So from here I can just have my AB. The LCM is what? ABC. If I say C in ABC is remaining just AB. AB times 1 is AB. Minus AB here will go out. It remains C. So we have 2. Put my C close to it. Bracket what? A minus B. Because C times this will give you this. Now from here I'm still having my K to the power of 1 over A equals to this K. Now we have AB minus 2C times A will give you 2AC, minus times minus will give you plus 2BC all over what? ABC, right? So from here with what we have here, I can still take my 1 over a, like they are equal here. You can see equal base equate each other. Since I have k here, I have k here, so I'll write equal base equate this will equate this. Alright, so I'll be left with 1 all over a equals to what? AB minus AC plus 2BC all over what? ABC. So I'll just put it close to it here. Recall, AM equals to AN, it will equate each other. So my M is equals to what? N. So equal base equates. So from here, if I cross multiply, this will come here, right? So or since I have A here and I have A here, this can cut this out, or you just take this here. Any of them of any choice. But let me just take this A here, right? Or take this here. So what will I do? We're working towards the answer. If I take this here now, I'll be having ABC all over A is equals to AB minus AC plus 2BC. Now A will equate A. We're left with what? BC. So the BC will now give me AB minus AC plus what? BC, right? Now which is the collect like terms. The one that have B, you bring them together, right? So if I have the one that have B, I'll bring them together. So we're having BC. This one come here minus what? AB come here minus what? BC again, right? Is equals to what? Negative AC. Now from here, don't forget that this BC has 2 here. There's a 2 here, right? So when the BC's come here, be minus what? Minus 2 here. Minus 2 BC. Is that taken? So we have from here we'll move forward, and also when we expand, there's a 2 here also, don't forget that, and also there's another 2 here too. Sorry for that, right? And also there's another 2 here also. So if I take this, my 2 will be here. So let's move forward. We have 2, not 2 will be here, 2 will be here, 2 AC here, sorry. So let me move this. So meaning that we're having this, let me just take this out, right? So it will be BC is equals to what? AB minus 2AC plus 2BC. So when I take this here, I'm going to be having this BC, right, minus AB equals to minus 2AC plus 2BC. So from here, I can easily factorize, and I'll be having this. Before factorizing, I can bring the BC together. Look, I have BC here, B. So I can take it here. So I'll be having take this one to this side too. So this will give me BC minus AB minus 2BC is equals to minus what? 2AC. So from here, collect like terms. I have a lot of B here, B, so I bring the B out because I want to make B the solution to the formula from the question. So my B into brackets, we have C minus what? C minus A, right? Then we have minus what? 2C, right, is equals to what? Minus 2AC. So from here, C minus 2AC will give you minus C. So my B now into brackets, minus A minus C, right, equals to what? Minus what? 2ac. So if I make this a formula, I'll divide both sides by minus a minus c. So this will give me b will now be equals to minus 2ac all over what? Minus a minus c. So my b here will now give me minus 2ac all over what is coming here minus. I bring the minus out of having a plus what? Plus c. So minus will equate minus. So my b equals to what? 2ac all over what? A plus c. So proof. So if this video was helpful, don't forget to click on the subscribe button. Thanks for watching.